All right, so when we're naming organic compounds, the first three types of compounds in your in your data books on the table are hydrocarbons, alkanes, alkenes, or alkynes. The only types of atoms in these compounds are hydrogen and carbon. Okay, the ending of the name, whether it's an ane, ene, or ine, just depends on the type of bonding, if you have single, double, or triple. So for this first example, I have all single bonds, so we just count the number of carbons. 1, 2, 3, 4, 5. The prefix for 5 is pent, and since it's all single bonds, this will be pentane. For this next example, it's almost the same structure, except I have a double bond here. So that means that the ending this time is going to be ene. However, because I've got more than 3 carbons in the chain, I have to specify where that double bond is. So you always count the shortest distance. So we wouldn't count from this side, we would count from the left side. So this is carbon 1, this is carbon 2. So the double bond appears after carbon 2. So we indicate that by putting a 2 in the name. So this is pent-2-ene. For this last one, this is a pentane chain that I have here, just like the first example, except now I've got a group, a CH3 group branching off. So you name the parent chain first, which is pentane, and then to indicate a group that's attached to the molecule, you have to specify which carbon number it's branching off of. You always count the shortest distance though, so we wouldn't count 1, 2, 3, 4 from the left side, we would count 1, 2 from the right side. So this would be 2. There's only 1 carbon here, so the prefix is meth, and then we add a YL ending. So this is 2-methylpentane. When we get into compounds that do not contain only hydrogen and carbon, like alcohols, acids, and esters, and halogenated hydrocarbons, this means that they have additional types of atoms other than C and H. So alcohols are easy to identify. They always have an OH group. Acids have a COOH group, which looks like this when we draw the structural diagram. And esters are basically an alcohol plus an acid to give us an ester. The alcohol loses the OH, the acid loses the H, so basically we lose a water, and we end up with a COO group. So this is how we identify an ester. Halogenated just means it has something from group 17 attached to it. So here's the first example. I can tell from this OH that it's an alcohol. So the ending of an alcohol, the suffix is always OL. Because I've got more than 2 carbons, I do have to identify which carbon the OH group is attached to. So I've got 3 here, which means that the prefix will be prop. OH is attached to number 2, so this is prop-2-ol. This next one, I've got a COOH group attached. This means it's an acid. If you look at your data books, naming acids, you basically just need to know what prefix you're using. Okay, so we're counting the number of carbons, and then we put OIC, oic, as the ending. So for this example, I have 1, 2, 3, 4 carbons. We include this carbon when we're counting, the one that's double bonded to the O. So since I have 4, the prefix is butanoic acid. Okay, if we had 3 carbons, it would be propanoic. If we had 5, it would be pentanoic acid. For the esters, so remember this is a combination of an acid plus an alcohol. We basically lose a water group from here, and we end up with a COO. So the acids is a COOH, this is just a COO. So this is how we know it's an ester. When we're naming esters, it's basically 2 parts. So the parent chain, the one that comes at the end, is the part that came from the acid. And then the prefix of the name, this is like a branch off of it, and this is the part that came from the alcohol. So when we're naming the acid part, we change the ending so it doesn't have the OIC ending anymore. It's going to end in ATE. So we just switch the ending of the acid to ATE. So for this example, to count for the acids, we start with the double bonded carbon. So I start here, and then I count the next carbon in line. So there's 1, 2. So there's only 2 carbons. So this would have been ethanoic acid. We change the ending to ethanoate. Okay, the branch coming off of it, we look at the other oxygen, the one that's single bonded, and then we count the rest of the carbons. So in this case, there's only 1. So this would be methyl ethanoate. Here's another example. This COO group tells me that this is an ester. So this first half came from the acid. So we name that first. I've got 1, 2, 3, 4 carbons. So this would have been butanoic acid. We change it to butanoate. The first part of the name is the branch coming off. This came from the alcohol. And in this case, we have 2 carbons in the chain, 1, 2. So this would be ethyl butanoate.